Hardy and Weinberg equilibrium. Problems based questions, how to solve it, tricks. You would be knowing in this session. So, capital A, small a, capital A, capital A, small a, capital A, small a. What is this capital A? It is the dominant allele of the given population. What is this small a? It is recessive allele of the given population. It is homozygous. It is homozygous dominant. It is homozygous recessive. Capital A small a is heterozygous, or you can say heterozygote. Right. Now we are going to represent its frequency. Frequency for dominant allele, the frequency is represented as small p. For the recessive allele, the frequency is represented as q. For the homozygous dominant, capital A, the frequency is represented as p square. For the homozygous recessive, q square. For the heterozygous, it is represented as 2pq, not pq, 2pq. Right. So, dominant allele A, p. Homozygous dominant, p square. Recessive allele, q. Homozygous recessive, q square. Heterozygote, a and small a, 2pq. Right. Second basic thing you should know is p plus q is equal to 1. And third one, simply squaring on both sides, p square plus q square plus 2pq is equal to 1. P square is equal to so p square is equal to total number of homozygous dominant given in the population, homozygous dominant, by total number of individuals. by total number of individuals given. Q square means similarly you have to do total number of homozygous recessive by total number of individuals. Homozygous recessive by total number of individuals, right? So keeping all this in mind, we will do one question. In a population of 1000 individuals, okay, 360 belong to capital A, capital A. 480 belong to capital A, small a. 160 belong to small a, small a. Now, what is the frequency of allele capital A is equal to what? So, what is the answer is they're indirectly asking frequency of allele capital A. Indirectly, they're asking P. P square is equal to total number of homozygous dominant. It is 360. 360 by 1000 because total number of individual is 1000. So take square root on both sides. 6 by 10. So P is equal to 0.6. P is equal to 0.6. Right. Okay. Next question. At particular locus, the frequency of allele A, capital A is given as 0.6 and that of small a is given as 0.4. What would be the frequency of heterozygotes? What would be the frequency of heterozygotes? Okay, it's simple sum. So frequency of allele A means what is this value? Nothing but small p. What is this value? Q. What is the frequency of heterozygote? They're asking 2pq. 2pq is equal to what? So simply multiply 2 into 0.6 into 0.4. So 0.48. Right. Next we will see the latest Neet question. The frequency of the dominant allele. Frequency of the dominant allele A is given as 0.4. The frequency of the homozygous dominant. What would be the frequency of the homozygous dominant? Homozygous dominant, heterozygous, and homozygous recessive. So what is you have to find these things. So we know that what is frequency of A, P is given as 0.4. Q we know it 0.6 because P plus Q is equal to 1, right? A homozygous dominant means P square. You have to find nothing but 0.16. 0.16, right? Heterozygous means Q square you have to find, and homozygous recessive means 2pq. Here you may make a mistake. Not pq, it is 2pq. So all the previous questions from this concept has been solved. Thank you. Hope it is useful.